Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to talk about just a whole bunch of different problems related to this first semester. There's just going to be a mix of all sorts of important stuff in here that will hopefully get you ready for the fall final. So one of the most important things we did is definitely talking about quadratics, and I want to start off with kind of a word problem related to that. So this says we have an oversized truck needs to pass through a one-way parabolic tunnel like this thing. The units in the diagram are by meters, and the truck is 5 meters high and 4 meters wide. And we want to find the quadratic function which describes the shape of the tunnel. Okay, first, so this kind of quadratic, it's definitely going to be an upside down one. Obviously, it's going to be negative a value, but we need to figure out what that a value is. And the roots of it are -3 and 3, so you could use factored form, but you also know that it's you could just kind of think of it as shifted up, right? So you could do it with also just kind of like a standard form vertical shift kind of method. So we could say it like definitely has the structure of ax squared and then just shifted up 8, right? And we can just use like a point on here to figure out the a value. So maybe we'll use the 3. So we know this point is 3, 0, right? So if I plug in 0 for y and 3 for x, right? I can figure out a. So this is going to be 0 equals 9a plus 8. So then a would equal -8 over 9. And so my, quadratic equation, so maybe I'll just do this. This curve is given by -8 over 9. The negative makes sense again because we know it's open up, or open down, x squared and then plus 8. And you could definitely have also done that with factored form because you know the roots. And then the next question says, determine whether the truck will fit through the tunnel. So the dimensions of the truck is what's going to be important here. So it's one way, so it can go right down the middle. And the truck is like 5 meters high, and it's 4 meters wide. So basically, we got -2 and 2. And the question is really a matter of the clearance, like in these corners right here, right? Because if at this spot you're not up at 5, then you wouldn't be able to pass through. Maybe I should say if you're not up at 5 or more, because obviously if you have more clearance than the height of the truck, then you're good. And honestly, you probably need more clearance than 5 because you're not going to scrape the truck down through the tunnel on the corners there. So what I would just do is plug in these roots of 2 or -2 and see what the height is, okay? So we have the equation over here. I'll use that. So we just want to know what the height value is at like a root of 2 or -2. And so if you simplify that, you're going to actually get 4.4 repeating. So what this means is actually like the 5 is not here. The 5 is like higher up, somewhere like that. And, this point right here is a height of 4.4. And so that means you won't be able to do it. No, it won't fit because the truck is like too tall for the tunnel. All right. Just a few more quadratic questions here, and they're really important, which is why I'm sort of stressing them. So you're definitely going to also just need to know how to solve roots, just given a quadratic like this. So if I was solving this one, you got these two negatives. I would just multiply by -1 personally to get rid of the double negatives because it's kind of annoying to have those. Then I probably minus 1 and multiply by 16. Get that. And then I'm just thinking what two things squared give me negative 16. So since something squared is equal to a negative, we know it has something to do with I for sure. And the number squared that gives you 16 is 4. So basically plus and minus 4i would be the two roots to this thing. These two things, if you square them, you would definitely get that. If you take a 16th of the square of those, you get negative 1, and so on and so on and so on. This question, so we have a kind of general standard form quadratic here, and you're told that m and n are integers, and it says the only possible value for x is negative 3. And the question is, what is the value of m? So the way I would think about this is basically, you know that there should be two roots to the quadratic always, right? And if I'm saying that the only possible value is negative 3, then that means we have like a repeated root situation. So, over at negative 3, we basically have some sort of open up quadratic, which just touches at one point like that. So we really know that x squared plus mx plus n is x plus 3 times x plus 3, because it must be the way this quadratic factors out. So we have x squared plus mx plus n is equal to, I'm just multiplying this, x squared plus 6x plus 9. And so then we can see that m basically has to be 6. All right. Just want to talk here about some kind of different just concept questions that we've run into. So one of the more confusing function transformations was some of these things on the inside where you're shifting a graph to the left and horizontally stretching it. So to do the shifts left or right, anything first off horizontal, left, right is horizontal stretch. That's always something to do with the inside of the function. And the weird thing is that it's always backwards. So backwards from maybe the way you think it should be. So here, if I have like a function and I want to shift it like 2 to the left, I don't do x minus 2, I do x plus 2. That would actually shift it 2 to the left. So you add inside. If you want to do a horizontal stretch, okay, you would sort of think that like you would put a big number on the inside, all right? But you actually don't. You need to put a number that is between 0 and 1. So you do something like maybe f of 1/10 of, should be x. And this would basically horizontally stretch the function by a factor of 10. So it would be 10 times as wide. So just remember, basically anything like horizontal, like inside, is always just backwards. All those weird, that's kind of like the weird part about those ones. If you want to shift them up and down, then you literally just add or subtract whatever that shift is. And if you want to vertically stretch it, you literally just multiply by, again, whatever that number is. This is going back a bit, but it's really important we know what makes a graph like a function or not. And that's the idea of the vertical line test. So, take a circle. A circle is not a function. It is a graph, but it's not a function. And that's because it fails the vertical line test because there's these two spots, one above the other here, where a vertical line would hit more than one spot. So this thing fails the vertical line test. Whenever that happens, if you have like a weird thing like this, some sort of graph like that, That also fails the vertical line test in a bunch of spots, and that would make it not a function. But if your vertical line, if you just, if you take, maybe a sine wave this way, this one passes the vertical line test. Doesn't matter where you draw a vertical line, you only ever hit one spot. And that's what it means to be a function. So these ones are not functions. This one is a function. All right. If a quadratic is in factored form, what would you know about that quadratic instantly? And the answer to that one is the roots, right? We've honestly already used it a little bit over like here in this problem. So, if we see a quadratic that's like 2 times x minus 7 times x plus 4 or something like that, we can look at those factors. That's in factored form, right? And we would know the roots of that thing are the opposite of those numbers inside. So like 7 and 4, okay? Very important you know the connection between roots and factors. And then this is honestly something that goes back to even, I think you see this in like elementary school or something, but what happens when you raise something to the 0 power and what happens when you raise something to a negative power? So 0 power, doesn't matter what it is, pi to the 0, 1/2 to the 0, negative 2 to the 0, 4 to the 0, all those things are just 1. Doesn't matter what you raise to the 0 power, it is 1. And then the negative powers, if you do things like 3/4 raised to the negative 2 or something, then the negative acts as a flip, so you get 4/3, and then it would be squared still. If you did something like 1 over x to the negative 2 or something, that negative again flips, so now it's up top on the fraction, and you still have like a 2. So the negative is nothing to do with negating the number. It has everything to do with flipping where the parts of the fraction are. And then the other number is still just tagged along like that. Same if this had been like a 20. This would just be a 20 now. All right. Another really important thing that we did was quadratic inequalities. And they're always a little tricky. So I want to make sure we do like 2 of these kind of here. So with these ones, the general idea is find the roots, make a really rough sketch of the graph, and then from there, answer it, okay? So I would move everything to the same side. This one actually factors nice. -2. And so now I know my graph sort of looks like we have a root at 2 and a root at 8, and we know it's an open up quadratic. And we are asked, when is it less than 0? This is the chunk down here that's less than 0, right? And so this is a problem that's like an and one, right? Any x value between those roots of 2 and 8 would work to make that inequality true. Make sure that you answer the question in the right dimension. So this is only one-dimensional problem. There's only one variable here. So you answer with one variable. I'm only using 2 dimensions to help me answer the one-dimensional problem because it's easier for us to see, this kind of thing in a picture than answer it this way. It's actually a very common trick in math to bump up a dimension to answer a question in a previous dimension. There's things like that show up time and time again. But yeah, and then just to do another one here, if you put everything on one side, I'm going to move everything to the right. I would get 7x squared and then minus 8x plus 10. And then probably just do quadratic formula because these numbers are kind of big. So I'm going to plug in all of this. And then the roots of this thing would be like 8. And then if you simplify that, right, this is going to be a negative number, which you don't even need to know what negative number. You can honestly just use that to answer it. So we know it's an open-up quadratic with imaginary roots, right? Because this part right here tells me the roots are imaginary. And so we have something like that, right? And we wanted to know, when is my quadratic less than 0? So here's my 0. Here's my quadratic up here. That thing is never less than 0, right? So the way I wanted you to answer these is to just say no real solution. Technically, there are ways to answer that with imaginary numbers, but I just don't want to get into it. So this is just the way we would answer it. There's no real solution to this quadratic inequality. All right. Another inequality that's always a little bit trickier in Algebra 2 are these absolute value inequality problems. And I kind of have a few multiple choice things here coming up that are just kind of, I don't really like multiple choice because I want you to be able to know how to do the problem, but I think it's good considering those silly tests like SATs and ACTs. They're loaded with multiple choice that you should know how to use them to kind of answer the question. So so the way we do this by hand is, we could put the absolute value on one side, and it would be an and or an or problem. But we can also, if we have answers, you can always just test some of the answers and kind of the solution spaces, and maybe eliminate some answers is the idea. So an easy thing to test is 0, right? If you test 0 here, right, you're going to get -8 plus the absolute value of -7. And the question is that less than or equal to -51? This thing on the left, right, is going to be just -1, and that is not less than -51. So we just plugged in 0, and it didn't work, which means I can eliminate that answer, and I can eliminate that answer, right? Then, if I was using the answers to solve this problem, just pick something in this one that's, this last one is no solution. So you can just test something like 7 maybe really quick. So you can do -8 plus 9 times 7 minus 7, and kind of ask yourself, is that less than or equal to -51? That's a horrible 51. And so in this one, let's see, you get 63 minus 7 in there, which is 56. And -8 plus 56 is not less than -51. So that means we eliminated this answer. And so the answer would be D. It's actually also really quick to just see the answer if you honestly just do one step. If you just move that 8 over, right, you would have had 9x minus 7 is less than or equal to, if you add 8 to that, it's still a negative number. And we know this is a positive number, and this is negative. And so we know that positives are not ever less than a negative, less than or equal to a negative. So that's one that you could have just done really quickly and just seen this if you had done it that way. But if I was doing the SATs and ACTs, I might not think of that right away and might just use the answers like I did to get the solution. All right. This one's just kind of important concepts about the imaginary number I. Its definition is, I just equals the square root of -1. And from that, we got, we were able to answer how many unique powers of I there are, and the answer is 4, because we have I. But then if you square I, right, you would get just rid of the square root and you get -1. And then I cubed, it's just I squared times an I, which is -1 times I. And then I kind of ran out of the room here on the last one, but I to the fourth is just like an I squared times an I squared, which is -1 times -1, which is 1. And so as soon as you get to a 1 in math, now any powers just restart, right? It would cycle back. I to the fifth is equivalent to I, and so on and so on and so on. I to the sixth is equivalent to I squared. So we actually never write this kind of stuff in math because it should be simplified. Like, you should never actually write anything but I to the first power. You might run into I squared and you just write -1. You might run into I cubed and just write -I. You'll never, ever, ever write I cubed in math, or I to the fourth, or I squared, or any of these other ones, because all of them simplify to something very nice. And the trick was with remainders. So if you have, so the only things you ever write are I, -1, -I, or 1. And this one, so this is the powers, I guess, all right? And these are the remainders. And so this is no remainder, right? Because if it's a multiple of 4, there's no remainder. If there's a remainder of a quarter, you would write I. If it's a remainder of a half, you're the second one in the cycle of 4, so you'd write -1. And then remainder of 0.75, you would write -I. So the way to do this kind of thing is to take that big number and you just go and divide it by 4. And so if you do this big number down here divided by 4, you get 0.25 as a remainder. And so that means that it's like this, right? This whole thing right here should just be written as I. This is something to a 0 power, so it's like times by 1. And this is just going to flip the -2 around, so it's 1 over -2. And so then, if you just multiply all that across, right, you would have I over -2. I think everyone would agree that this thing is a lot simpler than that thing. All right. So another very important stuff is that we did this semester is systems, and this is a system of like nonlinear equations, and we've got a quadratic and a line, and quadratics and lines can intersect in up to 2 spots. So if we have like some sort of quadratic, we could have a line cut across it, and we could get like 2 points of intersection, which is why you see some of these answers have 1 solution or 2, because you also could get 1. You could draw a line that just hits the vertex like that, and then you would just get like 1 solution. So you can do this a few ways. I mean, you could just do it out by hand, and you could do like substitution elimination stuff. Or if you have solutions, you could always just use those to try to answer it, right? And so I'm just going to go and use the solutions, kind of show you how I would maybe do it with multiple choice. So 1 and -1, they have to work in both of these, right? So if I plug in 1, -1 to here, I'm going to get -1. Well, I need -1 to equal 1 minus 6 plus 4. And if you do that out, right, you get 1 minus 6 is -5. And 1 minus 6 is -5. And then -5 plus 4 is -1. And so it really does work. So we know that 1, -1 has to work. 1, -1 has to work, so that if you don't see 1, -1 like this one, it's not a solution. Also here, it's not a solution, right? So now it's just a matter of, is it doing something like this line and giving you just 1 point of intersection, or is it got like 2, right? So let's just test 6, 4. So 4, does that equal 6 squared minus 6 times 6 plus 4? And so 4, let's see, we got 36 minus 36 plus 4, so that's nice. So that one works. And then does negative 2 times, what was it, negative 2 times 6 plus 2 times 4? Does that equal negative 4? I'm just plugging into the other equation. And you would get negative 12 plus 8, and that equal negative 4. Yes, it does. So that one's good. And I kind of jumped the gun, honestly, with this one because I only plugged it into the first one. We need to make sure that it also had worked for this one, and I just knew that it did, which is why I skipped it. But you really need to make sure that you plug the 1, negative 1 into both of those. So if you plug it in here, you really should have tested it before we moved on. So negative 2 minus 2, you can see, does actually equal negative 4. So both of these points work, so that needs to be the answer for the system. It's basically like the purple line up here, where you got 2 points working for the common intersection. So that's the correct answer. All right. This is just another system of equations problem that's kind of interesting. Is kind of different. So this one is really annoying, honestly, if you try to do substitution, but it's actually not that bad if you do elimination. So these two things, there's some stuff that's very similar between them, right? You have xy, and you could kill off a term with the x's if this had been 3 over x, right? And then you could subtract, and you could get an equation with just y. And so that is actually where I'm going to start. I'm going to multiply this thing by 3, because then I'm going to have 3 over x plus 9 over y equals 9 over 4. And then if I just take this one and put it down below, right, you can see that I've kind of got that nice setup for elimination. So I would just subtract these two. You kill off that term, right? Then 9 over y minus negative 2 over y, you would have to add the top there. You do have common denominators, so you'll get 11 over y. And then 9 fourths minus 5 twelfths, you don't have common denominators, so you need to basically times this by 3 and this by 3 to be able to subtract those fractions. And 27 over 12, which is that term here, 27 over 12 minus 5 over 12 is going to give you 22 over 12. And then you can solve this anytime you have a fraction equals a fraction with a variable on the bottom. You should cross multiply. And you also, though, can just use proportions here, because you have 11 on top and 22 on the top over here. So the way to get this to this is multiply by 2. So this, really, if these things are equal, has to just be half of 12. So basically, y has to be 6. And then x is, you can use any of the other equations. You could do 3 over x minus 2 over y, which is 6 now we know, equals 5 twelfths. And if you simplify that thing out, you're going to get it has to be 4. And then for some weird reason, this question wanted x plus y. Oops. X plus y. And x plus y is 6 plus 4, which is 10. So those are just a few problems. There's so much other stuff that we did this semester, but this is just a little quick sample of some of the kind of most important questions.